Hello guys, and welcome to our first webinar in CST titled CST Introduction to the Tools Needed to Build Your Project. Okay, as you see from the first image, welcome to our CST, Computer Simulation Technology. In this we will learn the tools needed and what we need to create a project and how we can start with this amazing software. Let me first define myself. I am Ihab Hassoun, telecommunication and network engineer. I work on CST for 4 years and as a freelance for different projects and write different papers in antenna design. And my friend Sarosh Ahmad from Pakistan, who worked with me in this webinar and different topics. Anyway, in this webinar, we will start by CST as a documentation, as you see, and through the documentation, I will go to CST and show you how we can work with it. So it's not only a presentation, as you see, the slides only. No, we will go through CST and see different things on the software and build real time with the software. So what is CST? It's computer simulation technology, founded in 1992 with 170 employees. Worldwide distribution network focused on 3D simulation. You have different techniques in CST or different softwares built in with CST, like CST Design Studio, CST Electromagnetic Studio, CST Practical Studio, and Multiphysics, etc. Okay, it's a worldwide. You can find in Europe, in America, in China, India, and different countries. As you see here, it's an amazing software. Everything related to electromagnetic will be designed by CST. So if you want, you can find the documentation in CST. When you install CST software, you will install directly different documentation for different application in it, like CST cable, CST design, and electromagnetic studio, etc. Okay, so this is the documentation installed in CST. In CST, you have different tutorials and different examples. So you can download a tutorial or example about design, not only antenna design, maybe a circuit, maybe a waveguide, maybe a filter. So you have a lot of examples related to this amazing software. As you see here, like a telephone and the human body or a head. And you can go through online help maybe in CST directly, or you can go to committee or contact the CST support to have or to buy maybe some component or to ask them about different things. And sometimes you will find the help when you build an object or when you work with the transient solver. So let me start by CST directly. When I go to the software, or when you open the software as the first time, you will see this page. Maybe you will have this project, maybe not. This project, when you create a template for a project, it will be here. The template will open here because you created it before. Or you can delete the unpinned project. So I can delete it, okay? And here, you see the models and tools related to CST, like Antenna Magos, which have a lot of antenna design in it, or different designs related to antenna. Okay, you have CST filter design. Maybe you installed these softwares, maybe not. IDEM, Spark 3D, etc. Okay, and in the left you have these tools like save as, open a folder, or new and recent, like here, new project. And component library. As I told you before, you can install a components here, and you see an examples or tutorials related to CST. This is a built-in. Some of them will be free, and maybe you will ask for a design and you pay for it. Okay. And here you have the help documentation, as you see in the slides. And you have options. Maybe you want to change the settings, maybe the color. Maybe you open CST for the first time and you see the quick start guide. So maybe you want to open it again, so I can click it here or not. Depends on you and what you want to see. Okay, and maybe you want to change the path or to see the updates and add the ribbon, customize the ribbon, etc. Okay, so you have different settings here, and you can work on it and see the lines of your design. What I have here as maybe FS3D, Spark 3D, maybe antenna maggots, it's not work with you, so you should see if the lines work with antenna design or antenna maggots and different software related to CST. Okay, so let us start. New and recent. Here I can choose new project. So let me create a new project and see how we can create, or what is the steps in this way. Firstly, we have microwave and RF and optical. Okay, so in this one I have antenna, which is we work here a lot. Okay, because I am an antenna designer, so I work here a lot. But CST not for antenna only. For microwave and RF or optical, I have antenna, circuits and components, radar cross-section, biomedical applications, optical application, and periodic structure. We have EDA, electronics, signal integrity analysis. So firstly, you say, what's my topic? What's the domain I want to work on? And according to that, you will choose your template. Okay, you will choose your working design. Maybe you have design rule check or narrowband model extractions. Okay, EMC and EMI, radiation emission, conducted emission, PCB rule checking. So depending on this, you will choose. Okay, beam optics, space applications, and we have statics or low frequency to choose magnetic design, maybe, or sensors. Okay, so depending on the design, you will choose your way of work. Okay, let me here choose antenna and press next. In antenna, we have different categories. Maybe I want to design a waveguide like horn or cone antenna, or a planar antenna like patch, slots, etc. Or maybe wire like dipole, or folded dipole antenna, or any type of wires antenna like helix, or any type. Okay, or maybe phased array and unit cell. Maybe mobile phone integrated, maybe reflector, maybe electric resonator, or RFID tag. So depending on the application, I will choose. Because CST will build the template of your work depending on the object you want, or depending on the environment you want to create. Okay, so when I want to create a patch, let me choose planar, not wire. Okay, I will choose patch antenna. Here we have different type of simulation for this kind of antenna. You have time domain, frequency domain, and multi-layer. So depending on the results you want, maybe you want a time dependent, frequency dependent, you want a specific frequency to calculate, or you want a wideband or multiband antenna. So depending on the results you want, you will choose your solver. Okay, so not this is the way. Maybe I will want to create a radar cross section. Press next. You see here monostatics, B-statics, time signal radar. So depending on the project you want, okay, depending on the project you want, you will choose the environment or the tools needed. Okay, let me create here antenna next, patch, and press next, and I want to choose time domain. Okay, here we have different properties like dimensions, frequency, time, temperature, voltage, current, etc. Okay, so maybe the dimensions of your project will be in centimeter or a meter. Okay, micrometer, I don't know. Depending on it, you will choose your dimensions. Okay, so if all the data in centimeter, don't choose millimeter and multiply it or divided it. Okay, choose the units you write. If it's centimeter, choose centimeter. If it's millimeter, choose millimeter. Okay, And the frequency also, maybe the frequency is terahertz or kilohertz. So depending on the frequency, choose it, like gigahertz here, or the time also and the temperature. Okay, so depending on your project, choose the units. Next, here is the frequency mean and the frequency max. Hopefully we can change all these parameters in CST also, but from my experience, please put it directly from here. Let your environment created is work fine from the beginning. Okay, didn't change it from CST. Put it here and let from here work. Okay, for example, I choose 2 giga to 3 giga or 4 giga. Okay, and here we have a monitors. In simulation, we will see later on, we will go to simulation and see a monitor. In monitor, we can request the result we want. Maybe I want the E field, maybe I want to see the H field, the far field, the power flow and power loss. Or maybe I don't know, I need all of them, I need only the far field. So I will choose the frequency, 2.5, semicolon. In the semicolon, you see, I can add another frequency I want. So the separation between them, as you see in the example, is the semicolon, okay? Or I want a single frequency. So depending on me, maybe I want 10 frequency, maybe 1, okay? So the separation will be a semicolon. Next, you see here, antenna planner, the template name. So this will appear here. Dimensions, millimeter, frequency gigahertz. The solver is time domain solver. You see, it's printed microstrip, PFA, slot, spiral. It's kind of planar antenna, okay? When I press finish, they will go on and create my template. Okay, so to create your template, if you go to file, I think you will see antenna planner. Okay, the template I created, it's appeared here. So next time when I open CST, I will see this. Maybe if I want to create the same environment for a new design, I can press it and go on directly. Okay, let me wait and start. Okay, when you open CST, you see it's untitled 0. You can change the name when you press save, but till now the project is created. And I can go through them step by step. Let me go to PDF and see what's in it. The common user interface, it's the interface for all CST. This is the navigation tree. We will go through it in CST directly. You have the menu bars, you have the primary window and the toolbar. This is the message window. When you start the simulation, you can read here the message or the feedback. And we have a parameter. You create a parameters for the design. Okay? And here you can choose if you want to see the navigation tree, the parameter list, or you want to undo this. Okay? We have here different tools or shortcut to use in CST. No need for them all, but we can use it. Like rotation, you can press Control. In plane rotation, you press Shift. Control Shift, you panning the screen or the window. You can press Space Bar to reset view to structure. Control F to reset view. Shift plus Space Bar at the same time to zoom into selected shape. And mouse wheel dynamic zoom to mouse pointer. Okay, before I go to the shapes, let me go on through CST and let me know what is this, what I can see here. Okay, this is your window. When I press 5, I can change the coordinate of X, Y, Z. Maybe when I play with the numbers, maybe 3, you see, I change the coordinate. But when I start, always I press 5 to see it in front of me. Okay, the Z will go through me. Anyway, this is the navigation tree. This is the trees, the folders I have, component when I want to create the models or the object I have, the group, the materials I choose. Here we have pack and vacuum. Pack, it's perfect electric conductor. which means sigma is infinity. Faces, when I create faces, will appear here. Curves, WCS, which means the coordinates when I have specific coordinates. Wire, voxel data, when I want to create a human, like blood materials, etc. Dimensions, when I see the dimensions here via views. Anyway, I will go through them step by step. The excitation signal, this is the signal I have. Okay. It takes few times because I open different software now. This is the signal. I can change it. Let me go through it later on. The field monitor, because as you remember, I request the far field at 2.5 gigahertz frequency. We can add different things to field monitor. We will see it later on. We have the mesh, the control, and this is files for the results. When I start the simulation, after I finish my design, we will have here 1D result, 2D, 3D result, far field, and tables. Okay, so for units, maybe I want to change the units. Okay, I will start with millimeter for dimensions, temperature, frequency, and time. Maybe I want to change it, so I can change it and press OK. Okay, so we can change it. The simulation project, you can see all blocks as 3D model, all blocks as schematic model, and you can change it here. Okay, we have type of solvers. Maybe you want time domain, frequency domain, and different type of solvers here. Okay, and if you choose this type of solver, maybe you want to change here no signals. I will add maybe some source to show you how to change the settings in the solver. And after that, we can start the simulation directly by start simulation or from the solver when pressing stars. We have optimizer. Maybe I want to optimize the design. I change different things. Maybe I want to add a parameter here and give him the maximum, the minimum and max, the initial and current and best. Okay. So this will be calculated later on, but we can goals. What is my target? Maybe I want S11 less than 20. So I put maybe the width from 10 to 15 millimeter and let the simulation start, and they give me the best S11, for example, for this design. Okay. And the parameter sweep tells it that this parameter will vary from this number to this number. Okay. We have here the mesh view. If I want to see the project as a mesh view, as you see, and the global properties, maybe I will want to change the cells per wavelength. So maybe I want to create more meshes in the design, so I change it per wavelength. Okay, so here we have different settings we can work on. Maybe I want to specialize and change different things on it, or maybe I want to simplify the models and change this. Okay. So usually I don't work with mesh. If I have problem, I work, but usually not. Okay. So depending on your problem. Anyway, the edit properties, the history list, what I did till now, nothing. But if I create a object or I create a models as a 2D or 3D models, it will appear here. Okay. Or add a ports, etc. So everything will appear here and I can change it. We have a parameters. We have the problem type, high frequency, optical cable, low frequency, so we can change it. And we have a calculator. Maybe I want to write an expression and press calculate to get the result. You see here help, I can press it and see what is calculator for. Okay. And we have macros. In macros, we have different things or a lot of things, because in macros, we can edit macro. We can write a VBA code to work with CST. Import it or edit or move or delete a VBA macro code. Like the Excel file. In Excel, I can write a VBA code, and here also I can write a VBA code. So we can write a code in CST. Okay, maybe you want to design a shape via your code. Okay, so we can do it. Here we have calculate. So maybe I want to calculate something. Maybe I want to calculate the analytical line impedance. So I press it and I will choose the coax strip line differential strip line, I can choose anything, okay, and calculate it directly. I can write here, for example, 2.1, and here 4.353, for example, and here for the epsilon r 2.1, it's not depending on the frequency, and press calculate. You see, you calculate the impedance. Maybe you want to change this to got an impedance, okay, change the impedance. You want 50 ohm, you will play with this 1.7, for example, to got impedance close to 50, okay. We want 50, so we can choose everything we want, okay. Anyway, this is type of impedance calculation. Let me press X or exit. We have constructed some existing examples like voxel statics, coils like helical antenna, or like discrete port, convert discrete port edge port to a discrete phase port. You will see it later on in the documentation. Discrete port with lumped element, multiple discrete port. We have filters. I can construct a band pass filter. We have parts, vias, etc. Okay, we have a lot of things here. Maybe materials, we want to create call, model material. Maybe I want to, here we have it, to export an image, PowerPoint presentation, documentation. So not only one thing, it's a lot of things here, okay? So we can find a lot of things here, like a solver, the result, to import result, use spice or filter analysis, parameters, we have materials. We want to create, import CSV data from refractive index. So maybe you have a material as an Excel file and you want to open it. Maybe you want to create a graphene material for optical application. So you can do it here, okay? So we can do a lot of things using macros. I don't know, or I don't want to go through all of them because it takes 1 hour only for this macros, okay? So let me continue. Here it's the modeling, and we will finish it. Here is the modeling. In modeling, we have import export. I can import 3D or 2D object, or I can export it as a 3D or 2D. Like I want to export the PCB or the Gerber file or the XF file, I can export it. Or I want to import shape from SolidWorks, from AutoCAD, okay? I can't import any shape from different software, as you see, okay? A lot of softwares. But here the version will depend, okay? This is the problem with CST. In CST, I can open an old file if I have a newer version, but if I have a version which is from 2015, I cannot open a file on 2019, okay? This is one of the problems. We can solve it by simple trick. We can export the file. Okay, I can export the file and put, instead of 2019, a old version. Okay, so when I do it, I can open this version in my old CST. Okay, this is one of the trick. Okay, guys, so I can export or import any object I want. I can change the background I'm working on, the material of background. Maybe I want this to be a water, so I can change it, or maybe a wood. So I can change it, okay? The space of working. And here change different things on it. Maybe I want to see the materials. It's a CST library, maybe Rogers, RT-Duroid 5880. Okay, we have a lot of materials here. Maybe I want to see if the wood exists here. Okay, it exists. So I can search about it or search one by one. Okay, guys, maybe I want to create a new material. So I add to library a new material, or from here, new materials, and you can add a new material and give the new material properties. So maybe I will give a specific color, specific epsilon r and mu, specific name, and all the properties like conductivity, dispersion, thermal mechanics, and density. Okay, when you create it, the material will be added directly to the material. So when you load the material or create a new one, it will directly open with in this folder, okay, materials folder. Then I can go with the shape. As you see in the here in the file, we have different shape like cylinder, sphere, break, elliptical cylinder, cone, torus, rotation, and extrusion. So let me go step by step from here. Here we have to pick edge. So first I will create the shape, then we will go to the tricks in CST to pick a points or edge points or middle point or the center of the face or points in the circle or the center of the circle, and a lot of tricks in CST. This will help us a lot. Okay, so let me, as you see from this documentation, we have different things. We're working with coordinate to change the coordinate, the 0, 0, 0 coordinate to a specific place. So I will go all through them by CST. Okay. And also we have the Boolean operation like add, subtract, intersect, and divide. Okay, so let me go through it also. And finally, we have the curve modeling tools to build 2D shape, like create a circle or create a rectangle or a line, or maybe I want to write an equation, and from the equation I can get the shape. After getting the shape, I can extrude this shape to be a 2D shape or 3D shape. Okay, so we have a lot of techniques in CST. I will go through them step by step. Okay, like here we can create a modeling shape by equation. You see, we add equations and we got the shape. So let me go through CST and go with the models I have. So firstly, I can create a box. Maybe I will create a box directly here. I give him the weight and height and the length also. So I have the properties of this. Maybe I want to change the material or the component. Maybe I have a new component or in component 1 in this folder. So I can create it directly. You see? Component 1, solid 1. If I want, I can go and change the properties. Press OK. You see? I change it. But here I should go step by step to it. This is not work. Because when I want to change any parameter in this, I will go through it and change it. But if I put it as variable D, press OK. D will be minus 100. Okay, before it's minus, so it's not a big problem. So here in parameter list, if you see, I create a new variable, which is D. Maybe I want to change D to 100. Press in the figure, you see, to update the parameter, press F7. Some of you, F7 not work with him. So for that, go to home, press parameter update, parametric update. If F7 not work, if it's work, press it directly and it will work, okay? So we have two options. Maybe go to home and press parameter update, or as you see here, parametric update, or press F7, okay? And you can directly see it. Another way, we can press this, press ask to show dialog box. I didn't create it, okay? Press ask, you have, yes, see, I can put it as name. I can put any name here and put maybe dimensions like minus WW, minus LL, from 0 to T as a thickness, and change the material, load from material. I will put it as aluminum, load, to show you how it's worked, okay? Let me press load. After pressing load, you will see that aluminum does already exist in the project. You want to, yes. Okay, close. Here we have aluminum, preview. Give me the value of W. I will give it to 20. The description, width. Okay. Length, 20 also. The description is length. The T will be 1. The description will be thickness. Okay, here we have the object. Okay, you see it's a different color, I think, because aluminum have different colors in the pack. Okay, no problem. Material, we see aluminum. Okay, when I go to solid, I can see this is the solid one. When I go to name, this is the aluminum one. Okay, I can press Control, as we see, as a shortcut, and rotate. Maybe I want to rotate. Okay, we can rotate by here using this. Okay, or right click, press rotate, or directly press Control to choose. Space will go to reset view. Okay, that's good. Here we create a box shape. We can create a sphere like this. Escape, the name, the orientation, the segment. Maybe I have 3 segments. The center radius will be 2. The top radius will be 3. The bottom radius will be 1. Let me choose to vacuum. Preview. The radius is, the top radius is larger than the center radius. Please check. Okay, this is 3 and this is 2. Preview. I don't see it. Okay, it's here. Let me put it as 10. Preview. Okay, that's it. And here 5. So let me put it as 100. Okay, that's it. 2. Let me press OK. Okay. I create any shape with segment 3 because I changed the segment, so it's not a sphere. Okay. This is a kind of object I create. Okay, with 3 segments. I have a cone, so I can create a cone with bottom radius, which is 2, and top radius is 5. Here it's large, so let me put it 20 and 50 to see it. X center. For the Z, I will put T, and the material will be vacuum. The solid, it's 3. It's not a big problem. So let me press View. Okay, okay, okay. View. So if I want to see it, let me zoom in. So I can press this zoom mode and choose as a rectangular to zoom on the shape. Okay, let me press 3, and you see this is the cone. Okay, because I choose this values, the cone is like that, but I can change it to maybe here to 10, and you see preview. Okay, now the cone will be appear more. Look to it. It's like a dish antenna. Okay. Let me change it to be better than this. Let me put it as 100 or 200. Okay. This will be more realistic. Anyway, this is the cone. If you look to it only, you can see it. The bottom is like that and the top is like that. Okay. We have torus. I can create torus like this to large radius and the small radius. We can change the material and the component, and or press help to see how to create it. Okay. And finally we have here, let me press this arrow. We have cylindrical shape or elliptical cylinder. So we have 2. Okay. For cylinder, maybe I want to create cylinder with outer radius 10, and let me see, it's 100. Preview. Let me choose this. Let me put it as 100 also. Preview. Okay, that's it. You see, this is a cylinder. And what happens if we have an inner radius? Let me see. Let me press OK. If I zoom in, okay, this is a cylinder. Nice, but no hole between in it. So it's a full material. Okay, let me create a cylinder with a hole. 100, 90, 0 to 200, 200. Preview. Okay, look to it. When I create a radius or an inner radius, you see, this is the inner radius and this is the outer. So the thickness of the cylinder will be between the inner and outer. This is kind of amazing tools in CST. Okay, we can create any shape we want using this. That's fine. I like this kind of tools in CST because it's more easier than any software you want to see in antenna design or electromagnetic design, from my opinion, because I like this kind of software when I want to design any shape I want. Okay, so here also we can change the location of this, the name, the aluminium material. I can go to transform, and in transform I can translate, rotate, or scale and mirror. So maybe I will translate it from a position to another position using this arrow or using the data here. For example, for y put it as 0, for x it's minus 164. I can copy it to save this or not copy. This will be here. Okay, so we have two options. Maybe I want this and this, so press copy. Maybe I want this one only, so remove copy. Preview, okay, it will be there. Okay, so depending on you what you want. Okay, that's it. Maybe I want to, let me change the position of solid 1. Right click on solid 1, press transform. Maybe I want to rotate it. Here will not look, I can rotate. Okay, depending on which. I can press copy to have different, these two. If I press copy, I will keep this and change the image of it. Okay, so I have this. Okay, let me press OK. We have this too. We have two shapes. Look to it. We have two shapes because I choose OK. Okay, guys? So I can work with CST with different tools. I can scale. Maybe I want the scale to be 0.1. Preview. You see? It's very small. Press OK. So solid 1 will be this. So using these tools, it's really very amazing. I can right click and reset view or press space. So using these tools will be amazing. I can translate, rotate, scale, and mirror. For example, let's use this name, right click, transform, and choose mirror. Okay? You want a mirror to which axis? Maybe x-axis, maybe y-axis, maybe z-axis. 2000 coordinates, so I press here 1, preview. I have a mirror in 000, okay, because I choose it. I didn't change it. Maybe I want to change to 10. For example, you see, let's go to 10, but I want it to 0. Press 1. How many repetition factor? You want one mirror or more? So maybe you want 2, 3, 4, 5. How many? I want 1. Okay. Copy to have this one and this new one. Okay. Press OK. You have this mirror. Press shape. You have a mirror. The same distance between 0 to this and 0 to this. Okay. So a lot of tools in CST. Let me, for example, have the Boolean. In Boolean, I can add objects. I can subtract it, I can intersect and insert, and also imprint. Okay? We can choose if there is intersection between the object, okay, if I have intersection or not. We have a lot of intersection here. Anyway, for example, we have this and this and this, and also this, not. We have a lot, so I can add them to have one component. So if you see, this is the whole, the 3 or 4 components as one component, solid 2. Right click, let me separate shape. Okay, I cannot here. Shape tools. Let me separate the shape. Here we cannot. Okay, because it's intersect. Anyway, so we have different components. Okay, so and also I have different tools. Maybe I want to use the band shape to make it as a curve. or maybe cylindrical band, maybe band layer SketchUp. We have modify locally, modify the phase, define phase constraint, show phase constraint. Maybe I want to solid to shell conversion. Maybe I want to fill up surrounding space. So we have a lot of tools here to use. Maybe we want to blend, maybe to align, okay? And we have also the curves. I create the 3D shape and I can create the 2D shape. Maybe I want to create the 2D shape as polygon, line, circle, ellipse, arc, rectangular spline, 3D polygon, 3D spline, analytical curve. Maybe I want to give it as equation, cosine of t, sine of t, and here z tangent of t. Give t from 0 to 1 or pi over 2. Press preview. Let me press space. Okay, let me press out of the domain the tangent x, no problem. 2 times t. Reset view. Okay. So if I want to press analytics, this is the shape I created. Okay, it's any shape, okay? But I told you that we can create an analytical shape. Okay, we can create an analytical curve. We can blend this curve, we can chamfer this curve, we can trim curves, we can delete the segments, trace curve and hill curves. Okay, we can do a lot of things here. And also, maybe I want to create a rectangle. Let me go but by press space and let me create a curve which is rectangular. Okay, let me create it here. So I create a rectangular and press it as a rectangular one. Okay, then if I want, I can extrude this. I can press the extrude face, or I can here the extrude curves. Okay, so maybe if I have 2D face, I can extrude it, or maybe if I have to rotate the face, or here to extrude the curves. Okay, because here I create the curves, so I can extrude here. You see, when I go the mouse, it's lighted. Okay, press it 2 times. You can give a thickness. Let me press it as a T thickness. We can choose a twist angle or a tapered angle, and you can choose the material and the name. Let me press OK. We have now this one, which is solid 3. We create new shape. You can go to this shape to see the history tree. It's kind of curves. It's rectangular curve. Okay, then we extrude the curve to have a 3D model. Okay guys, so I can create any 2D shape or analytical. Maybe I have an equation and I want to create analytical curves, then I go to make it as a 3D one. Okay, that's a very amazing task or very amazing tricks in CST software. Okay, really it's very amazing to do it like that. Anyway, let me continue. We have here blend to trace from curve, to conform strips from curve. We have this also, and we have these tools. Bond wire, we create a spline or JEDEC bond wire. We use this in different applications, but not here. Okay, so no problem about it. We can pick a point. As I told you before, I can pick a face, pick face chan, pick similar faces, pick edges. Maybe I want to press it. I can choose this edge. Okay, and to clear it, you can press clear. Maybe if I want to press F, I can pick a face. So I mentioned this whole face, clear the picks. You see here, F is pick face. Maybe I want to edge, pick edge chain, pick edge from coordinates. We have a lot. Okay, we can start by learning them when we go through applications. So when I go with the application, I will use them. We can pick a, let me press here the arrow. We can pick edge center, pick end point, pick face center, pick point on circle, pick circle center. Okay, for example, I can pick the edge center here. I press this edge, and here we have a circle. And the specific one, I want to align my WCS, the coordinate system, to this point. I press it. You see, the coordinate, the 0, 0, 0 coordinate will be here. Okay, so I can start from here. Or another one, I can press local WCS to go through to 0. Okay, the first one. Or maybe I will pick the face, press F and double click on it. We pick the face and we press align WCS, and we align our coordinate to the face. Okay, as you see in the top of the face, I align my coordinate. Let me edit properties, maybe to this shape. I can edit it, close, history list. I can see what I did from the beginning till now. Okay, and we can change this one, update or steps or run to or edit the steps and see. Okay, that's great. I can work with WCS and maybe rotate it, maybe give it as a rotation V, for example 180. For example, preview, as you see, I change it. Okay, so we can do a lot of things with this. This is amazing tools to align the WCS when we have a difficult shapes and you want to create it easily. So you change the coordinate to a specific points you want. So maybe I will press P and choose my points here and align WCS to be at this point. Okay, so you can align the WCS to any tricks you have here, to a pick, to a points, to a face, to anything. Okay, let me local this to be 0 and 0, 0, 0. And we have the cutting plane. We have this as a cutting plane. So you see the half of the planes to see what happens inside it. It's for a specific application. Okay, depending when you go, you will see the face. Okay. Anyway, let me see it. We can zoom in and zoom out. Anyway, don't worry about this. Is for the cutting. Okay, so when you choose this, so the cutting will be different. Okay, no worry, this is 0, it's perfect. So I can go with the cutting depending on the position I want, or X, and I can't through Y. So you see, we can do a lot of things with this. Anyway, after finishing with the modeling, as you see, we can go to simulation. In simulation, we have, as you see, simulations. All the parameters or the properties depending on the simulation. We have frequency. See, I put the frequency 223. I can change it. But as I told you before, I prefer to put it as the first time, and we can press help to see what this means. We have the background. I can change the background also, and the boundaries. Maybe I want to change the boundaries when I work, for example, in metamaterial. I want to change the boundaries to electrical, magnetic, open, add space, periodic. So unit cell, depending on the applications, I can change the boundaries. Okay, let me choose this. In simulation, we have a waveguide port, and maybe I want to add a waveguide port. The best way to add a waveguide port is by choose the face. For example, here, let me pick the face, this one. And when I press waveguide port after choosing this face, look, directly my waveguide port will be there. Okay, so I can add it like this. That's a great way. When we have a coax, we add it like that. Or we have a rectangular antenna or rectangular waveguide antenna, we add it like this for the waveguide port. We have discrete port as a discrete port or discrete port to wire face. So we have here, we can pick 2 points, like for example this points and this points. Okay, or we can choose 2 conductors and put it as the center of the edge. So maybe I choose, let me press OK. Maybe I will for example, from here, I can press the middle of the edge and add it to the middles. Okay, so we have different way for that. Maybe like that. Maybe I press M, the middle of this edge, and M for the middle of this edge. And let me create this. sorry, let me create this. You see, it's a discrete port between these two. Maybe I want to change the voltage or current, or put it as S parameter and change the impedance of it. Okay, so depending on me, what I want, I can create. Okay, guys, we have plane wave, we have lumped element. Maybe I want to add a capacitor, maybe I want to add an RLC serial, RLC parallel, diode, spice circuit, or touchstone. So depending on me, what I want, I can create. Maybe I want to keep L and C 0 and add only a resistor with 100 ohm and to a specific position, or I press the points between. So maybe I want to add it here. This is work for what we say reconfigurable antenna. When we add circuits to the antenna, okay, we can do it like here and press element 1, or I can rename it to resistor 1 or anything else. Okay, here we add the lumped element, lumped element to wire, multi-pin lumped element, sub element, etc. For the signal, we have a new excitation signal. I can add a new excitation signal or keep the signal as it is. Okay, we have the field import and field source. In field monitor, we request the result we want. I request at the first time the far field at 2.5. Maybe I want E field, H field, field source, power loss, magnetic. Maybe here we want to power loss density to calculate the SAR. Okay. So some parameters may be needed, some parameters may be not. Maybe I want to see only all the parameters, so I can request all the parameters. What I need to do is choose one, choose the frequency and press apply. And it will directly appear here in field monitors folders, okay? That's great. So we learn a lot of things. I hope you try by yourself all these things, okay? I hope that, guys. Anyway, after field monitor, we have voltage monitor. So we can see the voltage monitor, current monitor, field probe. Maybe you add a field probe and want to see the calculation. I don't use all of this, but depending on your application. So you use it depending on your application. Maybe you press setup solver. You see here, now I can see the properties in it. Maybe you want to start all support at the same time. Maybe I want only port 1 to work in mode 1. Maybe I want port 2 to work. Maybe I want to press selection, and the excitation maybe depends what I want. Okay, maybe I want to change the amplitude, maybe the phase. So maybe I want to use sequential, maybe simultaneous. So depending on me what I want, it will work. Okay, let me choose all ports. Maybe I want to choose one or all mode. The accuracy, usually it's 40. Maybe you want to change it to decrease the time of simulation to -20, and maybe you want to increase it to -80 to have a better accuracy. Okay, but usually it's 40. Hexahedral or hexahedral TLM, depending on the mesh type you want to run. Homogeneous port, you press it to see the result in a correct way or more precision way. Calculate the port mode only. So you have a lot. Maybe you want to normalize to 50 ohm, maybe not. So all this will change depending on your application. Okay, the optimizer you want to use, the bar sweep element. Here we create a parameter. So maybe I want to change the parameter from 20 to 120. So depending on me what I want, and press apply to start the simulation depending on this. Okay, let me press close, start the simulation. Maybe I want to use the acceleration. I want to CPU, change the settings to have more results in less time. So we have here, we have different things to change as parameter. Maybe I want to change this. I want to calculate all of this, or maybe not all. Maybe symmetric, maybe not. So adaptive mesh refinement, use sensitivity analysis. So you have a lot of properties you can change. Okay, and if you want to read about all, you only press help and you will see this all parameter. But usually we didn't work on this. Usually we put the accuracy and start the simulation. Maybe you change the port. Maybe you want to use optimizer, but not all of this at all the time. Maybe you need it. So depending on the application, as I told before. And when the solver changes, some parameters will change also. Okay. Here you have mesh, global, the intersection check. To check the intersection between mechanics, for example, check. If you have any intersection, you have intersection between elements. Okay, let me press OK. And you have another intersection, let me press OK. So you have intersections between elements. Yeah, because I create a random element, okay? Or random components. Okay, guys? So let me go to post-processing. Here we can import or export the result or as ASCII code to go through TXT file for maybe to read it in MATLAB for S11 or any type of results you have. Maybe you wanted it as an Excel shape or Excel sheet. So you can do it when you read the TXT file or TXT file from Excel. Maybe you want the S parameter calculation, I diagram, you have the I diagram. You have a time signal here. Sorry, I press I diagram, waiting for it. So we have a lot of tools in the post-processing. Maybe you want to calculate the SAR after the simulation. Okay, so I can go and press SAR to calculate it. So here is the I diagram, properties. You have yield analysis, spice extraction, transmission line and vector fitting. You have loss and Q, result template. Maybe you want to request some result as a 2D, far field antenna properties, filter, generate 1D. So depending on you, what you need to have. Okay, maybe I want the loss from E, so I requested. Okay, here we didn't have any simulation for that. Anyway, I will create this. You see, I will create this, and after I simulate, I will have this result. So from this, it's very important because not all the result will be here, because you should request the result you need. Okay, you should request the result you need. Maybe I want S parameter, and from it I want S parameter is time getting, Y parameter, Z parameter, extract permittivity and permeability from S parameter. So I can choose anything I want, and it will calculate directly. You see here? As you know, for extracting material properties as permeability and permittivity, you need S11 and S21 in the equation. So they request it and give it. You can press help to read all these tools. Okay? Anyway. And here also we have the view. This is not very important, but we use it a lot because you can, let me press space, you can remove the working plane or edit. You can wire the frame, you can see this as a wires. Let me see it. You can remove the axis or edit, bounding box or edit. You can show what you want to show. Maybe I don't want to see this. Let me hide it, so I cannot see it now. Okay, or I will show it, so I can show this. We can hide alls and show alls. Okay, we can export the image. Maybe I want to export this image to a specific folder like desktop 3d.png, so I see this image in 3D. But before we export it, let me do this. We sure remove everything to code the image, because we want to add it in a paper maybe or in our thesis. So it's better to remove everything and got the image. From my opinion, you can do what you want. Okay, and here we have the dimensions. Maybe I will change the dimensions, and you see it's the dimensions here. I have CST 2020, so maybe if you have an old version, this properties not exist. Okay, or some tools not exist, but in 2020 all of this exists. Maybe 2090 also exists. Okay, we have rotate, we have the pan to change it, we have the reset view, we have the stage view. In stage view, maybe I change the background, so maybe your background not like me, white color. Okay, maybe you have this one, so it's different. Okay, so first color for me it's white. I choose always this color because it's more easier for me as a paper. Okay, when I want to create a paper or add this image to any document I write, it's better to have a white background. Okay, so here we can work with the stage. Let me close the stage. We have axis scaling, the cutting, as I told you before, and the window I want to see, message navigation parameter, as you see here. I can remove one of them or all of them or edit. Okay, and here we can change the style of this to below each other or across each other, etc. Okay, so here it's the properties we have in this antenna design. So let me go to modeling or save my project as webinar 1. Let me save it in a desktop. Let me call it webinar 1. WB1. Let me save it. So the name will be WB1. Okay. And let me go to documentation to see what we forget to describe. We forget the loft operation. We will start by it. Okay, the loft operation is the way to create a horn antenna. It's the same way as a rectangular waveguide antenna. It's the same, or cone antenna. We will create it as a loft operation. We have bending to maybe create a helix antenna. I told you about it. The blend to change the edge of it. First, you select the edge, then you press blend or chamfer edge to change it. I will do it also. And the share operation to make it not have any thickness inside it. So let me do it and go on. Let me go to CST and let us delete everything we have. Yes. Okay, let me delete also the ports I have. That's great, and also the curves. Okay, that's great. So here, let us start. Okay, we have a lumped element, so let me also delete it. Okay, that's great. Okay, let us start. I will start by create a box which has a -10 to 10, -10 to 10, with thickness 1, and the material will be PEC, perfect electric conductor, preview, okay. Let me go inside, let me change the thickness to be 10 also, because it's more easier for us to see. 10. As I told you before, I can put it as a parameters to change it from here directly, or I can put it as a numbers. It depends on me, but I prefer to create it as a parameters. Okay, guys? Anyway, I have a component. Let me zoom in. Okay. Okay. Let me choose the edge. I pick the edge using E letter, or I can go here and instead of pick face, E, or press pick edge. Okay. I press this edge, and here I can go to blend. And blend, we have blend edge or chamfer edge. I can press blend. You will see the difference. The radius will be 0.1. Preview. Let us wait. Let me put it as 2. Preview. Okay, it will be more see from me. Okay, you see the difference. This is the blend. Let me press E again and choose this. And now I will chamfer it with 2. Preview. Okay, it will be. You see the difference? This is the chamfer. You cut from it as a rectangle, as you see. And this is the bending way. Okay, as a bend, it will be a curve, but here it's chamfer. So I cut it from it. Okay. So as I press E, you can see it also from here. If you look to it, this is the blend. It's a curve. As the chamfer will be as a rectangle, as a shape. I will cut it as a rectangle. Okay, this is chamfer edge. Let me clear the pick. You see, this is the way. Anyway, we have, let me delete it or keep it. We have this. Okay, guys, I will create another break. Maybe my break will be a rectangle, maybe a circular or cylinder. It depends on me. And I want to put it as -10, sorry, -20 to 20, or -50 to 50, -50 to 50, or no, let me say it's from 50 to 100. I will tell you because I want to change the position from 0 to here because I want to use new technique. Okay, and for y minus 50 to 50 it's not a big problem. For z will be 10. Let me press preview. Okay, instead of 10 let me take it to 50. Preview. Okay, that's great, but instead of 50 let me add 100 and this will be 120. Preview. Okay, that's great. So we have another object at this. We want to use loft. Why we want to use loft? Maybe I want to connect these two, okay, to create a new antenna or to create a cone or rectangular waveguide or any type of waveguide antenna, okay? We want to connect them or any shape. Firstly, we will go to pick face or plus F or pick face. You pick here. Then you will go to this way and press F also to pick it. Okay? We have these two faces because we want to connect it. But how we can connect it? We will go and use this one, the loft. Connect two picket face. Okay? Two picket faces. So, in this way, we can connect it. How? We can press preview. In the preview, as you see in the preview, I can connect it. I can change it. Let me change it. You see? It changed. I can change. It will change. Let me put it as 0.3 and press OK. You see, I connected. I connect these two faces and this way. So we have different way to connect it depending on the loft factor. Okay, I can put it as a variable and change it or put it like that. So depending on me. Okay, guys, let me press F here and let me also press F here. Why I do it? Let me now try to use the shape to, or maybe modify the shape, maybe, I don't know what I should do to make it whole. Okay, create a hole inside it. Okay, let me press reset view. Now I choose the faces. When you choose the faces, you can hold it. You can use the hole. Okay, let me first, if I have this 3, let me delete the 1 and 2 first. Okay, we have this. Let me first press F to press here, and let me press F to press here. Then I will go to Shape Tools. In the Shape Tools, Shell Solid, I can press it. Inside, the thickness will be 2, preview. So everything inside it, it will be removed. Okay? Let me press 0.1, for example, preview. Okay, the thickness is greater than it. Anyway, press OK. So here, if you look to it, nothing between, okay? Nothing inside it. I shell it using this Shape Tools, Shell, Solid, or Thicken Shell. And the thickness will be 0.1. So the thickness here will be 0.1. Press P. Press P. It's 0.1 here. Okay? Let me clear the pics and press Reset View. So I can do it like that. Here I put arbitrary numbers, but you can do it in a better way. Okay? Let me also press F and choose this. After choosing this, maybe I will create the waveguide port here. So I create the waveguide port, and now I have kind of waveguide antenna. Okay? This is the waveguide port. This is a inside nothing, so the wave will go on. Okay? So we can do it in this way. Okay. We use the shell operation, the transform option, we learn it, the local modification, we talk about it, and that's it. Okay. Here they tell you about different type of solvers. We have different type, you know. The type of solver, we can choose it depending on the electrical size, the geometry problems, the material models, material parameter, resonant behavior of the model. Maybe here you can choose frequency, the architecture of the workstation, the size of the architecture. So different things depend on the type of simulation you have. Okay? And also the excitation signal, as you see before, I show you how to change the excitation signal. So maybe you have it, maybe you want to change it. And here you have the frequency domain to calculate each point for the frequency. As you see here in the documentation, you can see what's the transient, what's the frequency. It's for here for electrical medium and large size problems or broadband, arbitrary time signal. Frequency domain will be for narrowband, single frequency. So we can use the type of solver depending on your application. Okay? And here some tables to, for example, if you have weak resonance, okay, time solver is better. Strong resonance? No, not go with this, go with resonant fast for frequency. Okay? For AR filter, for S parameter calculation only, okay, time domain. But for general purpose, frequency. It's the middle between strong and weak resonance. Okay? So depending on the application, you will choose the type of solver to use. And depending on the size of the structure, you will change this type of solver. Because maybe you have an airplane. So an airplane, you have a big electrically large dimensions. So for it, you can use integral solver or integrated solver. Okay? So for that, we can choose the types depending on the shape we have or the size we have or the properties of the application we have. Okay? For here we can finish our first webinar. It's really nice to meet you guys. Please don't forget to fill the documentation. We will upload in the comments section at the end of this webinar. So don't forget to do it. Okay? To have your certification. And for the second webinar, we will start to learn how to design the antenna by the calculations and go on to request the result by a professional way for you. And also we will try to prepare workshops so you have a short course about how to work with antenna and how to design antenna with different software like CST and HFSS. Okay guys, so thank you till now, and I hope this kind of webinars will take your attention. Okay, so thank you, and I hope I will meet you again in another work. Thank you guys.